All right, so welcome. This is Chapter 5, FN1, Evaluating Compositional Functions. So if you remember, we talked about compositional functions about a week ago. We said that when we have one function machine on top of another so that the output of the first machine becomes the input of the second, we create a new function. This is what we call a composition. Okay, so in this case, composition meaning in math, two functions, all right? So two functions more or less put together. If the first function, so g of x, and the second is f of x, the composition of f and g of x can be written in this form right here, okay? So meaning that we plug in g of x into f of x. So if it's inside the other, we know we're going to plug it in for that x value, okay? There's also other notations that we use. So for composition of functions, we say that f and then the composition of g we denote with an open dot. This is just another way that you might see composition of functions in the future. So please just have reference for that. All right, so the first one we're going to look at is given the functions f of x is equal to x squared minus 2 and g of x is equal to 4x plus 1, okay? What it wants us to do is find the composition of the function for f of g of 2, okay? So in this case, what we're going to do is we have the value of 2 in this case, so we're not solving for x, so we're going to plug in 2 for our first value. So in this case, g, so our first function g, which is 4x plus 1, we're going to plug it in for x, so in this case 2. So g of 2 is equal to 4 times 2 plus that value of 1. So in this case we just simplify. 4 times 2 obviously is 8, plus 1 will give me the value of 9. Alright, so that's when we plug it into g of x. Now we're going to take that same value, so that 9, we're going to plug it into my f of x. So again, we're just doing that composition. So we work from inside out. So we do the 2 into the g, and now we do that value that we got for that output, in this case 9, into the function for f. So we're going to plug that in. So f of 9 is equal to 9 squared minus 2. All right, so again, pretty straightforward math. In this case, we're going to have 9 squared, which is 9 times 9, or 81. Minus that value of 2, which is the value of 79. So in this case, we're going to write that notation again. So f of g of 2 equal to that value of 79. Okay? So that's my final output that I have for that function, all right? So the number's not too bad, right? You just kind of plug it in, you just kind of work from that inside out every single time. So we'll go ahead and try the next one. So in this case, what you'll notice is obviously we have a different value, which is negative 2, but we're also plugging in that value for f and g. So in this case, we're going to plug it into the f function first, and then into the g function later. So we'll start with that g function, or f function, I should say. So we're going to start with f of negative 2 is equal to negative 2 squared minus 2. All right? So we'll go ahead and simplify here. In this case, negative 2 squared, since it's in parentheses, is that positive 4. Minus 2 will obviously give you that value of 2. All right? So now, again, we're going to go ahead and take that value of 2 and then sub it in for g function. So in this case, that g of 2 is equal to 4 times 2 plus 1, okay? So obviously we did that up here, so 4 times 2 is 8, plus 1 will give us that value of 9, okay? And in this case, we got that g of f of negative 2 is going to equal the value of positive 9. All right, so in this case, again, that is what we get for that value for that composition. All right, so not too bad with the numbers. This is where you might run into some problems. So 3 and 4, plugging in with f of g of x. So in this case, what we're going to do is we're actually going to plug in the entire equation into another one. So in this case, if you remember, we have f of x is equal to x squared minus 2, and g of x is equal to 4x plus 1. Right? So g of x is that 4x plus 1. So we're going to take that function, and we're going to sub it in to that f of x function. So in this case, that f of 4x plus 1 now, right, is going to equal, now what we're going to do, we have that x squared up top, so that x squared now becomes 4x plus 1, and now squared, and then we're going to have that minus 2. So again, that 4x plus 1 is the original g of x, and we're subbing it in for the x value of the f of x function, all right? So now what we go ahead and do is we just got to go ahead and simplify. So in this case, that 4x plus 1, all right? Obviously, we have 4x plus 1 twice, so we're going to write it out. And that's going to be minus 2. All right, we'll go ahead and simplify again. So we get that 16x squared. Again, you can go ahead and use your generic rectangle if you still want. But we'll get 16x squared plus 8x plus that value of 1, and then minus 2 on that outside. All right? So now the last thing we got to do is just combine our like terms. So that f of g of x, and that's equal to 16x squared plus the 8x, and then minus 1. And now you're done. All right, so biggest thing you got to remember is you just got to plug in that f of x function, or that g of x into f of x. Now what we're going to do is we're going to reverse the process. So we're going to plug in that f of x function into g of x, all right? So in this case, that f of x function is the function of x squared minus x. And now what we're going to do is we're just going to plug in for g of x. So in this case, g of x, if you remember, was that 4x minus 1. So what we're going to do is we're going to plug in x squared minus 2 into that 4x plus 1. So in this case, that 4 multiplied with x squared minus 2 plus that value of 1. All right? So then we can go ahead and simplify. Again, we don't have a squared term, so we just can multiply each of those terms by 4. So I get 4x squared minus 8 plus that value of 1. And now, if we look, we can just simplify again, so that g of f of x function is equal to, now again, nothing combines with that 4x squared, so you just get 4x squared, and then negative 8 plus 1 will give me that value of negative 7. Alright, so that's our simplified version for that one. Alright, and then the last part, it says, how can you use the composition of functions to tell if two functions are inverses of each other? So you may remember that we actually did do these problems last week, and very simply put, in terms of how we can use the composition of functions to tell if they are actual inverses of each other. So if f of g of x and g of x, again I mean plugging in g of x into f of x, then it should be equal, we get g into f of x, so f of x into g of x. We know the value from those outputs should always equal x, all right? And you may remember those from 5.1.3. Again, that's when we use those functions to plug it in and then actually get that x value to see they were actually inverses. Then we know it's a function. All right, so we got those values. Again, I think this is very straightforward, but again, you can get confused sometimes, I think, with how many different numbers and different signage there is. So again, try to do your best to keep, I always try to keep it color coordinated because it makes it easiest for myself. So again, please let me know if you have any questions, but this is Chapter 5, FN1, Composition of Functions. So please reach out if you have any questions. Otherwise, have a good one.